Okay, so 8.3 is going to be the polar form of complex numbers, and we are representing those in polar form. So if you look at the complex number, it's called z. So z equals a plus bi. So a is the real number, b is going to be the coefficient of the imaginary number. And then, like I said, polar and trigonometric form, those are interchangeable. And then this is going to be polar form or trigonometric form, which is what you guys wrote down yesterday in your table. So does that look a little bit familiar? Okay, good. So then your r value, see how it says r is equal to the absolute value of z? Okay, so your r value is going to be positive. We're always going to use the positive r value. And that's going to be equal to the square root of a squared plus b squared, which is exactly like, it is like that, and our formula for r squared equals, yep, x squared plus y squared. Because if I were to solve this for r, I would just take the square root, right? And it would be the square root of x squared plus y squared. The only difference now is they're using a and b, but that's because we have what type of number? An imaginary. So it's in the form a plus bi, so it is the exact same thing. So it's the exact same thing you're used to doing to find r. Now, sometimes we'll refer to the number r as the modulus and theta as the argument. If you look at example 1, it says write each complex number in polar form with an argument theta. So that's how you'll see the vocabulary used. And the argument theta has to be between 0 and 2 pi. So I want you to notice if they tell you theta is between 0 and 2 pi, that means that our theta value has to be in what? Has to be in radians. So just for fun, as we continue on in this section, not only are we going to be finding things in radians, but eventually, not today, but eventually we are going to be switching back and forth between radians and degrees. So you'll have to be able to change that mode in your calculator. Okay, so whenever it says 0 to 2 pi, it'll be radians. What might it say if it's in degrees? Yeah, 0 to 360. Yep. Okay, so again, today we're in radians, but in the future we are going to go back and forth between our radians and degrees. All right, so what I did is I labeled your 3 steps that you're going to do this. So it says write each complex number in polar form. So that's what we're trying to do. We're trying to write this in polar form. Okay, and polar form is exactly what we wrote up here. So the z value is r cosine of theta plus I sine of theta. And again, that is what you did yesterday in your chart. So step 1, identify the quadrant of the point. We've definitely heard me say that in here, right? That should be your first step. You guys remember that from problem 9? Okay, so the first step is going to be to identify the quadrant. Your second step is to find theta using your tangent of theta equals b over a. And then your last step is going to be to find r using r squared equals x squared plus y squared, or r equals the square root of a squared plus b squared. Either way you want to think of that is fine. So go ahead and do step 1 and 2 for part A. If you can do step 3, go ahead and do it. I see some of you guys already did that. Okay, so if you're graphing negative 1 minus I, Simon, what quadrant is that going to be in? Okay, tell me how you know that. Okay. Good, so if you change that into coordinate form, then you can rewrite it. And I actually plotted mine, so I'll show you what I do. So negative 1 minus I, okay, I plotted this in the imaginary number plane like we did yesterday, but you could absolutely plot it in the rectangular plane and negative 1, negative 1. So you're going in the negative direction on x, okay, and then the negative direction on y, which means you're going to be in quadrant 3. Okay, so your final answer should be in quadrant 3. Okay, Alex, for step 2, could you tell me the equation that you set up?
Tangent of theta equals negative 1 over negative 1.
Okay, great. So tangent of theta equals negative 1 over negative 1. Okay, that's your b over a. And then if you're unsure where that comes from, your a value is always your real number. Where is your b value? In front of the I. So if you can't see a number in front of I, it has to be what? 1. Okay, and negative 1 divided by 1 is what? 1. So there's 2 places where the tangent of theta equals 1. We're looking for the one in quadrant 3.
5 pi over 4.
Okay, and then do you guys know what it is in quadrant 1?
Pi over 4.
Okay, you sound very enthused. Thanks. Yes, thank you. Okay, so yeah, it is pi over 4. So if you're looking at that and you're thinking, oh, well, I know pi over 4 is 1, just remember, whatever quadrant you're in has to match this point. And do you guys know a way you can take pi over 4 and find out what the equivalent is? Yeah, just add pi, right? So if you're adding pi, you have to have a common denominator. So if it's pi over 4, it's like you're adding 4 pi to pi, which is what?
Adding 4 pi over 4.
Yeah, which will be 5 pi over 4. Good. And then you could also use, and maybe Haley, did you use this to find it?
What?
Did you use your unit circle? Okay, so in other ways you could use your unit circle, right? Okay, so now for step 3, we're going to find our r value, if you haven't already. Okay, so r squared is going to equal the square root of x squared plus y squared.
So x is a, y is b.
Yep. Okay, so yep, so you're setting it up. R squared equals negative 1 squared plus negative 1 squared. Well, what's negative 1 squared? 1, right? 1 plus 1 is 2, so then just take the square root, and r is going to be root 2. And then what we're going to do is plug this into our equation. So our equation is going to be the r value. So I'm looking at this that I boxed in up here. So see how this is my r? So this is my r. And then my theta is 5 pi over 4, so it's cosine of 5 pi over 4 plus I, and then sine of 5 pi over 4. Okay, so I want you to go ahead and try number 2. And it's okay if it's not in a quadrant. Maybe instead of labeling a quadrant, you're just going to label the place where it is. Okay, so if you can turn it into a rectangular coordinate first, that might help. So let's see, is that our A or our B value? Okay, so what's our, what would our B be? Yeah, so negative 20, 0 is going to be your B. I know, you did good. I'm just going to have you see what you have.
I don't mean to sound depressing. That's not like me.
Yes.
I don't mean to sound depressing. That's not. I'll sound more enthusiastic.
No idea.
You're funny.
Okay, so then you can write that as a copy.
Quadrant 2.
I don't know.
We're just discussing. First thing, identify quadrant point. I'm right. You're wrong. Negative.
Okay, so think about, is that your A or your B? Okay, so if you guys are having trouble thinking of where to plot it, what I want you to think about is negative 20, is that your A or your B? A, okay, what is your B value? 0, because you don't have an I at all, so it'll be 0. So your point is negative 20, 0. So you're going to go ahead and plot that. And then again, it's okay if it's not a quadrant. Instead, we're just going to say where it is. So,
X-axis.
yes, this is on the left side of the x-axis or the negative x-axis. Or as I like to say, left side, strong side.
South side.
No, strong side.
West side.
My right side.
Remember the Titans, people? Come on. Left side, strong side. Remember the Titan fans in here? Best movie of all time. Okay. All right, and then your tangent of theta is b over a. So it's 0 over negative 20. If 0 is on the top, what is that going to equal? 0. Now, if 0 is on the bottom, it would be what? Undefined. When it's undefined, you're still going to have a theta value. So I'm actually going to walk you through that too. So you're asking yourself, where is the tangent of theta 0? And you know it's on the left side of the x-axis. So there's two places where tangent of theta is going to be 0. One of them is at 0. The other one, well, what else is right here on our unit circle? Pi. Does that make sense that this is the same place where pi is? Okay, so pi is going to be our theta value. And again, if you're having trouble, look at where the point is. If the point's on the axis, you're only going to have 4 answers that are on axes, and that's 0, pi, and then if we were at the top here, we'd be where? Pi over 2 and 3 pi over 2. So if it's on the y-axis, then it's going to be undefined. And if it's undefined, then you'd have either pi over 2 or 3 pi over 2. Because I'm going to have to get used to it for your hour. But thank you. Okay. So then you're going to write it in polar form if you haven't already. Do you guys have any questions about using that equation to write it in polar form? I know you did that yesterday on your chart, but I didn't know if that was okay. Yep.
So why would you use the cosine of pi instead of like the value of pi?
Oh, like instead of simplifying it?
Yeah.
For this, because you're writing it in polar form is keeping it in this format. As we go on in the chapter, we actually are going to start simplifying. Okay, so in case you guys didn't hear what Aaron was asking, he's saying, well, why do we leave it like this? Why don't we actually evaluate? Eventually we will. Today we're not. So if it says in polar form, you do want to keep it in this equation form. So the r cosine of theta plus I sine of theta. Okay, good question. Okay, so go ahead and do part C.
I'm feeling confident.
Cal, doesn't that hurt?
Yeah.
No, your eyelids get kind of dry. But like if you blink correctly, your bottom eyelid should be at the top.
Okay, so check your steps 1 and 2 and then do 3.
I forgot to put
Did you finish this
I didn't make it look bad.
I'll give you to tomorrow. R equals Q. Yeah. Okay, so you're gonna have to rationalize. So 1 over root 3, you're gonna multiply the top and the bottom by root 3. Okay, and then you'd have root 3 over 3 in quadrant 1. So where is the tangent root 3 over 3, everybody?
5 or 6.
5 or 6. Good. Okay, so your last step is to find your R value, and then you're going to write it in polar form. Okay, so what questions do you guys have for me on this? None? You guys are feeling good? All right, let's turn it over.